Let's do some conversions going the other direction now. So converting from a fraction into a decimal instead of the other way, which is what we were just doing. And there's nothing super fancy here. Really what we're going to do is long division. Everybody always tells me, students tell me, people on the street always come up and say, I just wish I could do more long division in my life. I just really would like to do more long division. And I say, well, let's do some fraction conversion. Let's convert some fractions into decimals. That'll be long division. And then they say, thank you so much. I really appreciate this helpful advice. Let's look at some examples. Fractions, of course, really are just division in some sense, right? We're sort of writing them as numbers, but it also works as a division. So let's take one that sort of you probably just sort of know off the top of your head, right? Something like 3/4. My guess is you would sort of be able to tell me, without even really thinking about it, 3/4 written as a decimal should be 0.75. If you think of it in terms of money, right? 3/4, literally 3 25-cent quarters would be 75 cents, would be 0.75. So how do we get there? How do we accomplish such a thing? The setup, right? So this is 3 divided by 4. So that's 3 underneath and then 4 going into it. Now you might say, okay, well, when we sort of did a little bit of division before, we didn't really get anything that fancy, right? And this would be sort of 4 goes into 3 0 times, and then I have just like 3 left over. So that's 3 out of 4. That's sort of just right back where we started. Hang on one second. Cat coming through. Hey, bud, will you hop down? Good boy. No more spills. No more spills in this house. Obviously, just sort of doing 4 goes into here 0 times, and then I have the remainder 3. It is not to use remainders here. So what I'm going to do is 3 is the same thing as the decimal number, 3.0, potentially even 3.00. We can, in theory, sort of add on as many sort of 0 decimal places as we need. To make this work, to sort of make this work as a division. So rather than just sort of get a remainder and call it a day, which in this case would literally get us no extra information, the idea here is, well, put these extra decimal places on, keep doing the division until essentially you run out of numbers, until it sort of finally finishes up with a whole value. What will happen is you'll get what we call a repeating decimal, which is sort of you get stuck in a cycle where you're sort of going through the same numbers over and over again. This one we think is going to become 0.75. So 4 does not go into 3, right? So there's a 0. In your answer, the decimal place just lives directly above wherever the decimal is in the number you're dividing into, right? So 3.00, you're going to have 0 point. So 4 goes into 30. That happens 7 times, right? Would give us 28. If we subtract, this is going to leave us with 2 left over. 0 comes down. 4 is going to go into 20. 5 times evenly, right? So minus that leaves us with 0.75. So we had to go sort of 2 decimals deep. We're going into the hundredths place, but we get the answer we expected, which is going to be 0.75. Let's do one that we maybe don't know quite so obviously off the top of our heads. Let's keep the numbers sort of small for now. Let's do something like 5/6. 5 into 6. So again, right, this means sort of 5 divided by 6, which of course means 6 going into 5. I know 6 isn't going to go into 5 evenly, so I'll throw a couple decimal places on here. What I normally do is I would maybe start with 2 and then sort of as needed, we'll put a few more on here. I maybe should have spaced this just a little bit further away from the last one, but we'll live. Another one, so 6 does not go into 5, so that's just going to be 0. Decimal place comes up, so we're really looking at 6 into 50. That would go 8 times, right, which would be 48. Subtract, that's going to give me 2, comes down and gives me 20 again. 6 goes into 23 times, which should be 18. Subtract 2, I get some more numbers, so let's put another 0 on. Bring it down. So that's 20. Now 6 into 20 is going to go 3 times. which is 18. And lo and behold, probably what you're yelling at your screen right now is don't keep going, because all that's going to happen is you're just going to get another 0, and you're going to bring it down, and it's going to give you another 20, and then you're going to put another 3 up top. It's going to give you another 18, and now you're just doing it again, and I just told you to stop. So this is going to keep going on and on and on and on and on, right? So what we're sort of getting as a result is this 0.8, and then this kind of infinite row of 3s, right? Literally 3s that go on forever. In theory, we could kind of round this off at some point. We're going to talk about rounding here in the next video, I think. So in theory, rounding is kind of an option, and most calculators will do something like that. But technically, I mean, a rounded number is not really the number, right? So if possible, certainly in trying to actually sort of do a conversion, we should actually sort of find what is the real number, what is sort of the actual number here. And so we have a notation for that. So the notation for a repeating digit is sort of a bar over the number. That kind of doesn't look like anything. It looks like a bar over a potato or something. So rather than literally write 3s forever, I'm just going to write 1 3, and I'll put this bar over it. So that indicates a repeating value. So this would be 3 3 3 3 3. Literally an infinite line of 3s sort of going off to the horizon forever. And the idea is to sort of be as efficient as possible. We'll just sort of write 1 3 and then put the bar over it. There's no reason to write 5 of them and then put the bar after that. You're sort of just wasting ink, right? You don't really need to. So just mark it as soon as you've got it. So this one is a repeating decimal. It isn't going to end. That's going to literally happen forever. We're just going to sort of get trapped in there if we don't use this notation to get ourselves out. We can do one more, maybe like a mixed number or something. How about something like, I don't know, 15 and I don't know, 7/8? Something like that. I mean, some of these you probably are sort of going to know off the top of your head, and some of them, if you're over 10, you're over 100, those kind of are obviously certain decimal values, right? 3 over 100 obviously just is 0.03, 300ths, right? So maybe not so necessary to sort of show those examples. What will happen here? One option, of course, is you could rewrite this as an improper fraction. 8 times 15 plus 7, get however much, and then divide that way. But there's no real reason to do that, right? I mean, this is just going to be 15 point, something, 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 right? So we only really need to convert this like 7/8. I just need to know 8 going into 7. 15 is 15, said the extremely knowledgeable math teacher. 15 is 15. Voila. So all I need to know is 7 going into 8, and I'll just sort of leave the 15 out of it. 8 does not go into 7. That makes sense. That's sort of how we got into this predicament in the first place. 8 does go into 70. So 9 would be 72, so we'll do 8 times 8, which would be 64. Subtract that would leave us with 6, so then the 0 comes down as 60. 8 times 8 is 64. 8 times 7 is 56. We'll see how far this goes. So if we're getting different numbers, 0 comes down as 40. 8 goes into 40 evenly 5 times. So this is sort of 3 decimals deep. It goes into the thousandths place. 0.875 is 7/8. That kind of conceptually, I hope, makes sense. And so all we're going to do is sort of leave the 15 where it is, and then we'll include our decimals, 0.875. And that's that. So just doing some quick, relatively quick long division here. And that's the basics of it. So you could get some of these repeating decimals. In theory, if you have particularly sort of, sort of unmatched numbers that don't really go together very well, you could end up with who knows how many sort of decimal places. But in general, I'll say sort of on the homework and the things that we're going to see in class. We're not going to ask you to do a division where you're seeing whatever 7, 8, 9, 10 decimal places. If you're doing one and you're getting that sort of deep into it, something probably went wrong, and you should maybe go back and check. So that's that. There you go.